the width is 12 mm, total length is 120 mm, and the bottom width is of the shorter leg is 90 mm. And this x-axis and this is a y-axis, right? This is a y-axis and this is a x-axis. We don't know the exact where it is lying, but it is for your reference to understand where will it lie. Okay, and this is your x bar and this is a y bar. Okay, so we'll try to solve it first. Now before starting to solve it, we have to divide this L section into two parts. Okay, if you can see in this image, we have divided into two parts. The bottom portion is the first drawing and the second one is the second. Okay, the longer edge is the longer part of the body is the second one. So now as per the steps, if you know that you have to first calculate the area, it is A1 of that section of the body. It is 90 into 12, that is the width is 12, so we get 90 into 12, that is 1080 mm square. Then calculate x1. It is how to calculate x1. What is the width? 12 mm. So center of that width to the axis. Axis is here. Your axis is lying here. So 12 by 2 will give the distance from the center of that section to the reference line. Next is okay 90 by 2. Why it is 90 by 2? You know, because your x is in this direction. X is horizontal, so 90 will be the distance, not 12. Okay, it is 90. Why? Because you can see here, this is your x-axis, right? This is your x-axis because it is your horizontal line. So when it says x1, you have to take this distance with reference to this axis. Half of that length you have to take of the 90. So it is taken 90 by 2. Okay. Next is y1, right? Next is y1. So for y1, what will be taking? Will be taking 12 by 2. Right? It is 12 by 2 because 12 is in the vertical direction, that is in the y-axis. So we will be taking half of that to the reference lines. Here there are two reference lines along the x-axis, along the y-axis. Okay. Now this is all the calculations for the first area. Now we will be doing it for the second area. What is the area of the second section? It is 120 into 12. The remaining portion is 120, and 120 into 12 is the size of the second body. Okay. Then we will calculating the x2 and y2. In this case, what will be our x2? X2 will be in the horizontal direction. How much is the width of that section? It is 12. So 12 by 2. It will be 6. If you can see, this is the width, right? And this is in the x direction. So we'll be taking the 12 from the reference to center of that part is how much? 12 minus 2. Understanding what I am saying? Why I have to take 12? Because the width is along the x direction. So we are want to calculate the distance of the from the axis to center of that body. For that, it is in the x direction, so we will be taking 12. If it was in the y direction, we would take it in the y direction. So next we have to calculate y2. To calculate y2, how much is the distance? It is 120 in the x y direction. So 120 by 120 by 12, obviously, because the total length is 120 including the first section width. If you can see, it is the can see here total width is 120 including the width 12 mm of the first section. So it is taken as 108 by 2, okay, plus 12, because the axis is at the base. So this distance, okay, half of it plus this remaining distance 12 mm. So whatever the height will is this will be our y2. Okay, so next is y2. Then you have to calculate the y bar and x bar. So what is the formula for x bar? A1 x1 plus A2 x2 by A1 x1, right? So when you substitute the values in this formula, you will get the value as 23.73. It is A1 will be 1080, x1 will be 45, and A2 will be 6. Okay, then x2 will be this 6. Okay, and next will be y bar, that is A1 y1 plus A2 y2 by A1 plus A2. It is area of the first object into the y distance plus area of the second object into y2 distance. Okay, this is a y2, second one, okay, by the area of sum of the area of the objects. This x1 and x bar and y bar are your center of gravity distance. Okay, it is very simple. Just find out the values and substitute in the formula. Okay, you will get the values. Next is to calculate the moment of inertia of a composite section. It is the L sections. Here also you are going to divide the whole angle into two parts. Okay, like this. Okay, the below portion will be the section 1 and the above portion will be the section 2. First, as I said in the steps, you have to first calculate the center of gravity of it. So for the figure 1, you have to calculate the area of it. So what is the distance? The distance is how much? 100 into 10. So it will be, area will be 1000 mm square. Next you have to calculate x1. Okay, what is the value of x1? Along the x direction, what is the length of the first body? It is 100 mm. So 100 divided by 2. Along the y direction, what is the width? What is the dimension? It is 10. So 10 by 2 of the first figure. Right? This is a figure 1. Now figure 2 is which? the above portion, this, right? So for that, what is I have to calculate first what area, 120 by 10. We can't take 120 by 10 because we have to minus the bottom width of it. That is included, 120 is included by the 10 mm of the first figure. So we have to minus it 10 mm and take 110 by 110 into 10. That will give you the area 1100 mm squared. Next is what? Y2 and x2 we have to calculate. So x2 is how much? Along the horizontal axis, what is the dimension? 10. So 10 by 2, right? Along the y direction, what is the length of the second figure? Is how much? It is 120 plus 10, but it is not actually 120, it is 110. So 110 by 2, okay, plus 10. You can see here 110 by 2 plus 10, that is 65. Now you have to I have calculated the required values for the calculation of center of gravity. So calculate now what? X bar and y bar. The formula for x bar and y bar is x bar is equal to a1 x1 plus a2 x2 upon a1 plus a2. Will give the answer for x bar, right? Next, once you substitute the values and calculate the with the help of the formula, you will get the value as 26.4 mm. Then y bar, it is a1 y1 plus a2 y2 by a1 plus a2, right? Once you substitute the values, you will get the answer as 36.46. With the reference lines, if you measure this distance, you will get the centroid of it. Okay. Then now, once you calculate the uh, center of gravity, now you have to calculate what? The Ig, that is moment of inertia of that figure, not whole section. We don't know what is the we can't calculate the moment of inertia of that whole L section directly, so we have to calculate separately first the moment of inertia, okay, that is Ig xx and Ig yy of figure 1 and as well as the figure 2. These are the rectangular sections. So what is your formula for the rectangular section? BD cube by 12 and DB cube by 12. So we have to use that formula to find the moment of inertia. We have to first find out the Ig, that is moment of inertia about the centroid of that figure. Okay, for figure 1, Ig 1x means the figure 1 and the x means along the x direction. So along the x direction, the parallel dimension is taken first. Along the x direction, whichever dimension is parallel to that x axis, that dimension is taken as first. Okay, it is BD cube by 12. If you can see in the object, okay, this is the first figure and this is the 100 mm which is parallel to the x axis. So we are taking this as B and the other side will be taken as D cube. Okay, that will be taken as D. Okay, so it is 100 into 10 raised to cube into 12 will give you 8333 mm power 4. Now Ig1y along the y axis. So when you calculate the along the y axis, B will be what? Now 10 in this case. Why? Because the parallel y along the y axis, whichever the dimension is parallel, that will come into, that will be the B. Okay, in this case the B is the value is parallel is 10 mm. So we'll be taking as 10. Okay, we'll be calculating the moment of inertia about its centroidal axis of that figure. Okay, now we'll be calculating for the figure 2. Okay, same way the for the second figure. Okay, in this case, along the x direction, parallel dimension is 10 mm. So we will be taking the b as 10. Understand? For whichever axis, okay, the dimension is parallel, that dimension will become the b for this rectangular formula. Okay, and same for the along the y for the figure 2. Once you have calculated the moment of inertia about its centroidal axis of that figure separately for x axis and the y axis, you have to calculate what the ixx and iyy about the whole section. So we know the theorem, that is the parallel axis theorem. So using that parallel axis theorem, we will be calculating the values. Okay, so what will be the formula? Formula will be igx, okay, 1 plus area into the h square. So how to calculate the h square in this case? So h square will be calculating, we know that the specific gravity, we know that center of gravity of that object with the from the axis. Okay, and we know the width of the object. Okay, so half the width of the object minus the specific gravity, center of gravity, will give you the h, that is a central distance from that object to the axis, that will be given. So if I draw and show you, it is, if this is your body and this is your axis, okay, and here is where somewhere your CG is, it is y, okay, and this is what the width. So distance which you calculate is this distance, okay, y bar minus y1 the whole square. Okay, we'll be doing like this. Half of this, whatever the distance is there, half of it will be the y1. Okay, you have to understand, it is very important here to understand this thing. So the formula is what? ig1x into area of the first figure, which we have calculated is in the start. Okay, then y bar minus 1 to the whole square, and then same for the second figure. If you substitute the formula, you get this. Okay, this is the ixx, that is this, right, into the area 1000. Then we have given you that y bar is calculated in the center of gravity. So the width is how much? It is 10. So half of it will be 5. So 5 is taken here in this case. So you have to do the half of the width. Because it is said y, you have to take along the y direction, the distance of the y direction. If it is said in x direction, then it would be x. Okay, we are calculating ixx, but we are taking the value as y. You have to remember this. While calculating ixx, that is second moment of inertia, we will be taking the opposite directions distances. Okay, this for ixx we will be taking y. Okay, same way substitute for the second equation, and sum of it will give you the ixx here. Next, for iyy, in this case, the calculation of the h will be x bar minus x1 to the whole square. Okay, if you see igx1, okay, it is not ixx, it is iyy, it is iyy, okay, and this is equal to ig1y, okay, and the second one is ig1 g2y, okay, it is not x, it is, this is correct, this is correct, okay. So if you substitute the values, you will get like this. Ixx is how much? X bar is given, this we have calculated, and along the x directions, so what is the distance? It is 100 mm, so half of that 100 will be 50. So whichever the distance, if this is x, then whatever the distance is there of that object along that direction, half of it will be the x1 and x2, okay. That you have done the same thing in the calculation of the specific gravity. Same way for the second half of the formula, okay, this ig2y and the area y2, so that is a2, and x bar minus x to the whole square, we get the equation value, but by solving that we will get the values, okay. The same way you have to calculate for the I section, okay, and for the T section. If the I section is symmetrical, what is my symmetrical? About the y axis, these dimensions remain constant, okay, and this width is same, then it is called symmetrical, okay. The width of the upper flange and the bottom flange, if it is same, then it is called symmetrical, okay. Then it is symmetrical along what? Y axis, that is vertical axis. If this is your I and this is your, this is smaller, right, and this is a bigger, then it is called asymmetrical, where you have to calculate same as this of the previous solved problems, where ixx and iyy will remain, the calculation, the formula will remain same, okay. In case of the symmetrical question, in case of the symmetrical questions, what you can do, you should not take the in I xx, okay, the formula will be ig x, okay, plus into area, the distance here will be is equal to 0. Why? Because y bar minus y will be 0, in which case, in the case where your x axis is symmetrical, okay. If your y axis is symmetrical, then your x bar minus x is equal to will be 0, so the formula will be this much only, that is ig plus a. But if this is 0, the area will also become 0, because you are multiplying a into h square, right. So what will be your ixx? They will be ig, that is whatever the calculation you do, this bd cube by 12 or db cube by 12, that will remain your ixx and iyy, ixx and iyy, right. That will be your same, because h becomes 0, so AH will become 0. So whatever is remaining is IG. So the IG is same. Okay, in what case it will become like this? In the case where your one axis is symmetrical. If y axis is symmetrical, then IYY will be is equal to IGY, right, plus 1 by plus GY2. Okay, but in the same case, when you're calculating IXX, okay, you have to calculating IXX, the formula remains the same, that of the above question. Okay, plus A into H square, it is y bar minus y to the whole square, that will remain same. Okay, that is the difference in the solution, nothing else. Okay, if it is symmetrical in the case of I sections. If it is unsymmetrical, then you have to solve it fully as we have showed in the previous problems for all the three, 1, 2 and 3 separately, and then sum it all. Okay, in the case of T section, okay, it will always be symmetrical along the y-axis. So in that case, your I YY will be only IG and IXX will be IG plus A into y bar minus y the whole square. This will be the whole formula for IXX. Only in which direction it is symmetrical, that in that direction